Good morning, dear students. I'm Amruta and I welcome you back to the lecture series on engineering mechanics. I hope you all are doing fine and enjoying this online classes. Good morning, Raghu. Yeah, let's join fast so we can start our lecture. Let me see at least 5 raised hands. With that, I'm going to start the class. Please join fast. Okay, so I'm not going to take a lot of time in waiting for you. Let me begin with the class. In our previous lecture, we have discussed about the composition of forces, and we have solved an ample amount of numericals based on the composition of forces, and I truly believe that you have gotten a very clear understanding about that topic. And you are given with questions also, and I would like to get the solution of those questions that I have given to you in the previous lecture as soon as possible. And if you have got any doubts, you are always free to ask here or in our WhatsApp group. Okay, so today's lecture is going to be about a process which is quite opposite to the composition of forces. So, and that particular topic is resolution of forces. So, what is resolution of forces? Resolution comes from the word resolve. Resolve means splitting or dividing, right? So, resolution refers to the process where we split or we divide a single force into a number of forces, okay? And these forces which are formed from the single force are called the resolved part of the given force or the components of the force. And this resolved part or the components of this force will be equivalent in action to the single force that is given, right? And it's exactly the opposite of the composition of forces or the addition of forces, right? In general, this resolution or splitting of force is done in two mutually perpendicular axes. So, if we are given a force, then we will be interested in finding out its component along the x-axis and another component along the y-axis. Now you can ask me, yes, good morning Sagar, good morning Preeti. Yeah, welcome back to this class. So if you are having any doubt, you can ask them in the chat box. Okay, I'm always ready to answer your questions. Okay, so coming back to the topic, I was telling you that a force is generally split into two mutually perpendicular axes, and those components are called the x and y components of the force, right? And you may ask me the question that previously we were forming a single force from so many forces, okay? And now we are interested in splitting a force into different components. Why is it so? The answer lies here that sometimes while solving problems, when we are dealing with problems of engineering mechanics or strength of material or mechanics of material, we are required to find out the equilibrium of the body, okay? For that we need to split the forces, okay, in horizontal and vertical forces, because we will not be always finding forces aligned either on the horizontal or vertical axis, will face some forces which are inclined, okay, inclined to either of this axis. So in such case, we have to find the forces along x-axis and forces along y-axis, so that we can analyze the equilibrium condition of the body. For that, we need to split the inclined forces into two mutually perpendicular axes, right? So, भावजी मस्त clear हो गए what is about resolution of forces and why we need to go for this. If so, then let's move ahead with knowing how to find the resolve part, or how to find the components of a force. So for that, let me tell you that in generally we find three orientation of forces. Okay, orientation means, as we know that this is our x-axis and this is our y-axis. Okay, the axis which is parallel to the ground is called as the horizontal axis or the x-axis, and the axis which is 90 degree to the ground is called the vertical axis or the y-axis. This much is known to everybody, right? Now coming to the forces, forces can be oriented in three ways. Either they will be lying on the x-axis, okay, or they will be lying on the y-axis. So we may find forces like this, some forces F1, F2, Ft. So these three forces are along the horizontal axis or x-axis, right? We may find some forces, suppose this is P1 and P2. These forces P1 and P2 are acting along y-axis, okay? And in some cases, in most cases, we will find forces which are neither acting along x-axis or not the y-axis, rather they will be inclined. You will find some forces, okay, let's take them as R1, R2, R3, R4. So this set of forces, they are neither along the x-axis nor the y-axis. This type of forces are called as inclined forces. Why? Because they have some angle of inclination with either the horizontal or the vertical, right? All these forces are having some inclination with the horizontal or the vertical axis. That is why we call them as inclined forces. Correct? Any doubt? Shall we move forward? So when we have forces, okay, horizontal forces with us, we are not required to find their components. When we have vertical forces with us, we are not interested in finding out or resolving that force into any direction. But when we encounter forces which are inclined in nature, we are required to find the components of it. Okay, and how to find those components? This way. Suppose I have a force F with me. This is my force F, okay, which is inclined at an angle theta with the horizontal or the x-axis. So the component of this force, okay, that means when I have to replace this force by suppose two different forces which can act along the x and the y axis, then I can remove this force and I can show the components of it as Fx and Fy. Fx refers to the horizontal component of the force, Fy refers to the vertical component of the force, and their magnitude. The magnitude of the horizontal component of the force will be the magnitude of the force multiplied with cos theta, and theta here is the angle of inclination between the force and the horizontal, right? And the vertical component of the force will have the magnitude of force into sine theta. Clear? The horizontal component of the force will be named as Fx, okay, and that will be F into cos theta. Vertical component of the force will be represented as Fy, and its magnitude will be F sine theta. You can observe here that the angle of inclination of the force with the horizontal here is theta. So, we are taking the axis which is close to theta as cos. Okay. You have to take the component as the cos component to which the force is inclined. Okay. And the other component will be the sine, F sine theta. Clear? Is this much clear? If yes, then we'll move forward and okay. Okay, thank you, Deepa. Okay, so with that knowledge in our head, can we go and solve this problem? All of you, please try to solve this problem. That I have a force, okay. I have a force which has a magnitude of 100 Newton, okay. Right? There is a force whose magnitude is 100 Newton, okay. And its angle of inclination to the horizontal is 30 degree. That means, what is the orientation of the force? This is the force, okay, whose magnitude is 100 Newton, and its angle of inclination with the horizontal. If this is my horizontal axis, this is vertical axis. So, this angle is given as 30 degree, right? So, what will be its component along x and y axis? Since this is the x axis, okay, and this is y axis, x component of force of magnitude 100 Newton will lie on this axis, and the y component of the force will lie in this axis. So, the component of force which will be along the x axis, we will call it as Fx, and its magnitude would be F into cos theta, right? Why I am taking this component as the cos component? Because theta is with the horizontal, right? So, what will be the value here? 100 into cos 30 degrees, and that is 86.6 Newton, right? Now, coming to the vertical component or Fy component, what will have? Fy as Fy will be sine theta. F is 100 into sine 30 degrees, and this is how much? 50 Newton. Why? Sine 30 value is, sine 30 is 0.5 and cos 30 is 0.866. Correct me if I am wrong somewhere. Okay, so we have gotten the Fx and Fy component of the force having magnitude 100 Newton inclined at 30 degrees to the horizontal. Is this much clear? Is this much clear? If yes, we'll move forward. And we'll see different cases of the inclined forces. If the forces are inclined at different positions, then how we will, and if they are in different quadrants, how we will find its components. Okay, thank you. Okay. moving forward, let's see. The forces will not be always inclined to the horizontal or vertical in a way that I have told you, right? The force can get inclined at any angle, not just 30 degrees, 60 degree, 45 degree. A force can be inclined at 75 degree or 43 degree or 32 degree with the horizontal or vertical, right? So for that, to solve problems with forces inclined at different angles, we have to have clear understanding on how to resolve forces, because most of the students, they make mistake while deciding the cause component and sign component of the force, and also with the direction, right? Because direction here decides whether the force will be positive or negative in nature, okay? And the cause and sign component will also decide whether you will consider that as a horizontal component or a vertical component, okay? You will make mistakes during calculation, right? So to clear that thing, we have to take different cases of the force. Here I have taken force in each quadrant, okay? The force F is lying in each of the 4 quadrants, okay? And it is inclined at theta degree with the horizontal, okay? And you can see that the force here, all the 4 forces here are pull type force. Pull, okay? Pull means if this is my point of application of the force is going outwards from the point. In this case also, the force is going outwards. Same here, force is going outwards. Here, the force is going outwards. So if a force is going outwards from the point, then we call it as a pull type force, right? And if the force is pull in nature, then its components will also be going outwards or pull type, right? You can see in every case the components of the forces will be pull type, okay? They will be going outwards, right? In the first quadrant, I have the force F inclined at theta with the horizontal. So its Fx component would be F cos theta as discussed earlier, and the y component would be Fy, and that is F sin theta. I think there is no doubt in this. So here this Fx or this F cos theta will have a sign, positive sign, okay? This will be positive, and the Fy will also be positive. Why? Because we as a convenience, we take rightward force, okay? Forces acting along x-axis and towards the right side are taken as positive. Forces along x-axis but going backwards or towards the left are considered as negative. Forces acting along y-axis and going upward are taken as positive. Forces acting along y-axis and going downwards are taken as negative. Okay, this is the convenience of sign that we can consider. You can reverse it, but you have to follow one particular convention which is comfortable for you, right? So here in first quadrant, the force is inclined at theta. So Fx and Fy both will be outwards. So Fx is acting rightwards and Fy is acting upwards. That's why we take them as positive forces, right? Coming here in the second quadrant, force is pull type. Pull type means it will act outwards, okay, away from the point. So its components will be also acting away. Fx will be acting in this direction, Fy will be acting in this direction. But this effects of this force F will have negative sign. Okay. Why? Because it is going leftwards. Clear? Fy is 50 in the previous question. Okay, we'll go to that and see. Now, this y component of force F is going upward. Okay, it's acting upward, so we can take it as positive. Clear? Now coming here to the third quadrant, the force is acting at 30 theta with the horizontal. So we'll have its x f cos theta along the negative x-axis and f sin theta along the negative y-axis. Since both these fx and fy components are acting along the negative axis, so I can take them as both them as negative. Clear? Now the last situation where the force is lying in the fourth quadrant, inclined at theta, right? So its fx and fy components will also be going outwards, as the force is pull in nature going outwards from the point, right? Fx and fy are also going away. So fx will be acting towards the right and fy will be acting towards down. Okay, so since fx is acting right, we take it as positive, and since fy is acting down, we take it as negative. I think all of you are clear about the sign. Yes? Is this much clear? Okay, fine. Okay. And one more thing, when we are taking this theta, okay, always try to take theta as an acute angle, because while solving problems you sometimes you will find obtuse angles also. In that case we have to convert that into acute angle and go about the problem, right? Now let us see some cases, okay, practical cases, and how to find the resolved parts of the force. Okay, I have a force F here which is inclined at theta with the horizontal, like we have discussed earlier. Now we are interested in finding out its component. So its component, okay, this component which is called as the fx will be, as discussed earlier, f cos theta, and this component, I am telling it to you repeatedly again and again so that this you will be clear and remember. Fy is f sin theta. Why I have taken this as f cos theta and this as f sin theta? Because the angle of inclination of the force is with the horizontal. Okay, theta is with horizontal. That's why this component will be f cos theta and the other component would be f sin theta, right? But in this case, come to this case where the force F is inclined at theta with the vertical. Okay, in such case what I can do, I can take this component, okay, the component, okay, of the force F. Okay, this component will be my cos component. So Fy here would be F cos theta and fx here would be f sin theta. Yes, because where theta is, okay, that component will be the cos component. Where theta is, that component would be cos component. Always remember, wherever you find theta, okay, if theta is with the horizontal, then that component will be the cos component. If theta is with the vertical, then that component is going to be cos component, right? Is this much clear? Any doubt? No. So let's, I have picked up two examples to clear your understanding of this theta orientation of the force with horizontal and with vertical. Okay. So in this first case, there is a force of 10 Newton inclined at 30 degree to the horizontal, right? So what will be this component? Fx component would be force into cos theta. So 10 into cos 30 degrees, and obviously this will be Fy, and that is 10 into sine 30 degree. Yes, put the value of sine 30 as 0.5, cos 30 as 0.866, right? Come here to this problem where I have the angle of inclination of the force, the same force, 10 Newton force with y axis as 60 degree. So what I can do here? Mukong kariparibeti. This will be my Fy, okay. This will be Fx. Since this is 60 degree angle of inclination of the force is with the vertical, I will take this as 10 cos 60 degree, clear? And this as 10 sine 60 degree. Yes. Now you may ask, the force is same, okay. The component, okay, in these two cases, are they going to be same? You can check on your own. See here, the angle with the horizontal is 30 degree, okay. That means angle with the vertical would be, since this is a right angle, if this is 30 degree, this has to be 60 degree. So the same case is written here, right? So I can take 30 as my angle of inclination to find the components of the force, or I can take 60 degree as my angle of inclination and find the forces. In both the case, you will get the same answer. Yes, you can check it. 10 cos 60. How much? Cos 60. What is the value of cos 60? 0.5. So 0.5 into 10, 5. Sin 30, 0.5 into 10, 5. Yes? Preeti. Yes, Preeti. Is there any confusion here? I think there is a confusion in sin 30 and cos 30. Sin 30 is 0.5, whereas cos 30 is 0.866. Okay. Similarly, you can check this out and let me know, right? Now let's check a different case. Here I have a force, the same 10 Newton force, okay, but the angle is given in a indirect way, okay. The force is at an angle 30 degree with the vertical like this. So if this is the case, how I will find the components of the force? Any idea? 30 is here, the force is going outward, it's an outward force. So its components will be this and this, right? This will be the x component and this will be the y component. and to find out the component, I need the angle, right? So my angle is given here. If this is 30 degree, so from the geometry, I can say that this is the alternate angle, okay? If this is 30, then this has to be 30 degree, right? And if this is 30 degree, the Fy would be 10 cos 30 degrees and Fx would be 10 sin 30 degree. Okay? In this case, come to this case where the same force 10 Newton is inclined like this. Okay? The force is having an angle of 30 degree with the horizontal like this. Then how I can find out the components? The x component is here, y component is here. If this is 30 degree, so from the geometry I can say that this is also 30 degree. So this will be this component, the x component will be f, sorry I am not going to take that value, I will directly put the value. This will be what? 10 cos 30 degree and this is 10 sin 30 degree. Can you see the differences, these cases? In the previous case, this component is 10 30 degree, but here it is becoming 10 cos 30 degree. Why? Because the angles are changed, reverse. In the first case, this was 30 degree, okay, force was inclined to the vertical at 30 degree, and in the second case, force is inclined at 30 degree with the horizontal, right? You can solve this problem in a different way also. I can, instead of taking 30 as the angle of inclination, okay, 10, this was 30, okay. Instead of taking 30 as the angle of inclination, I can take this as my angle of inclination. Yes, if this is 30, this has to be 60. So the Fx will become 10 cos 60 degree, Fy will become 10 sin 60 degree. I think you all are clear. If this much is clear to you, we can go ahead and see some other cases. Preeti, yes. No, ma'am, clear? Yes, ma'am. Yes, 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 yes. Okay, fine. Thank you. Thank you that I can make you understand this topic clearly. Okay. If any time, any point of time you face any difficulty in understanding, please raise your hands and ask your doubts. Okay. Okay, so moving forward, let's see some other cases. See, after solving this much problems, I think you will never have any doubt on resolving forces. Okay, if you are given with any inclined force, I'm sure, I truly believe that you will find its component without making any mistake, right? Okay. Now, we were talking about pull type forces till now. Now, let's see if a force is push type. Push type means if the direction of the force is towards the point. Okay, if this is the point or the body, okay, on which the force is acting, then the force is just going towards the point. If this is the point O, okay, and the force is going towards, okay, inward, then its component will also be inward. If the force is inward in nature, then its components will also be inwards, right? And all other things will be same. I have force of 10 Newton acting towards point O, inclined at 30 degree with the horizontal, then its component will also, this is its x component and this will be its y component. See, both these components fx and fy will be acting towards the point. Okay, in the previous cases the forces were acting away from the point. Okay, since the inclined force was acting away, its components were acting away from the point. Now in this case, the force is acting towards the point, so its components will also be acting towards the point, right? Clear? And all other things will be same. And you have to take care of the sign, right? If rightward and upward, then positive. If leftward and downward, negative, right? Here, fx would be what? This is theta, this is the force. So 10 cos 30 degree. Fy would be 10 sin 30 degree. But here, since fx, okay, direction is towards the left, okay, we'll take it as negative, minus 10 cos 30. And since fy is acting downwards, we'll take it as minus 10 sin 30 degree. Clear? Clear, right? While resolving, you have to keep two things in mind. The theta, whether it is with the horizontal or vertical, and the direction, whether the forces are positive. If they are acting rightwards and upward, then take positive. If acting leftward and downwards, take negative. And see whether theta is, where the theta is, with the horizontal or the vertical. If you keep these two things in mind, you can resolve any inclined forces without making any mistakes, right? Is this clear for everyone? Repeat again. Okay, fine. See, where I can do this. The force is push type in nature. Okay? The force is acting towards the point. Previously, whatever resolution we did was for pull type force. If this is point O, the force is going away from point O, right? This is point O and the force is going away. So if the force is going away, its components, this is one component, this is another component. So the components are also going away from the point, right? Now I have a force which is push type in nature. That means if this is the point, the force is coming towards the point, coming towards, not going away from the point. The force is coming towards the point, so its components, one component is this and another component is this. Both these components will be coming towards the point. For a pull type force, the force is going away, the components will go away. For a push type force, the force is coming towards the point, so the components will also be coming towards the point, right? So if now you saw that the x component is coming towards the point and in this direction, negative x, yes or no? If this is our coordinate system, see, this is positive y, this is negative y, this is positive x, and this is negative x, right? So here the force is going towards the negative x, so we'll take it as negative. That's what we have taken here. If the force is going downwards, okay, towards the negative y-axis, downward is negative y-axis, so we have to take the force negative. Going downwards, negative. Going leftward, negative. Going upward, positive. Going rightward, positive. In this case, the forces, the components were one was going rightward and one was going upwards. So we have taken them positive. Both the forces, Fx and Fy, we took them positive. In this case, both this Fx and Fy, Fx is going leftwards and Fy is going downwards. So leftward, downward will be negative. Okay? And theta is with horizontal. So this component, this will be the cos component. Since theta is close to horizontal, I have taken it as the cos component, and the other component will be the sine component. Clear? Preeti, is there any further doubt? Any further doubts? Shall we move forward? Okay, thank you. This case is done. Now come here. Here the force is same, 10 Newton, okay? And it's a push type force coming towards the point. So the components will also be coming towards the point, right? Fx, Fy, right? Theta is with the vertical. So I can take this as the cos component. This will be 10 cos 60 degrees and this will be 10 sine 60 degree. Why I have taken 60? Since I am considering this 60 degree and this is with the vertical, I am taking this as the cos component and this as the sine component. In an alternate way, what I can do, instead of taking 60 as my angle of inclination, I could have taken 30, this as my angle of inclination. Then in that case, Fx would have become 10, Fx would have become 10, Fx would have become 10 cos 30 degree and Fy would have become 10 sine 30 degree. I think you are clear. Since I have taken 60 as my angle of inclination and it is with the vertical, this component Fy would be 10 cos 60 and Fx would be 10 sine 60. But if I am interested in taking this angle, okay, the theta with the horizontal, then it would be 30 for me and this Fx would be 10 cos 30 and Fy would be 10 sine 30. So you know that 10 cos 60 is equal to 10 sine 30. Yes or no? And 10 sine 60 is equal to 10 cos 30. Clear? Clear? I think if this has become heavy for you, we'll end the class here. If you are interested in studying further, we can continue. I want to know your responses. Shall we continue or we'll stop here and resume it in our next lecture? Yes, I'm waiting. I want at least 1 or 2 responses because I don't want to burden your minds with a lot of information. So that you will be not remembering anything. I'm waiting. Shall we continue or stop here? No, I'm asking about should we go further or stop the class here and we'll resume it later in our next class? Okay, okay, thank you. I am literally happy to know your responses that you want to learn more. Okay, so let's finish these cases and in the next class we'll see some other cases, right? Here, coming to this problem, we have the 10 Newton force, okay, inclined at 30 degree, okay, but it is in the second quadrant. Up till now, we were discussing about, okay, problems in the first quadrant only, okay. See, all these forces, okay, were in the first quadrant. Since the force, inclined force was in the first quadrant and it is pull in nature, so its component were pull and both were positive. This was positive since Fx is going rightwards, it was positive. Since Fy is going upward, we considered it positive. So in all these cases, we were considering pull type force and in the first quadrant, right? So Fx, Fy both were positive. Negative. Where was it negative? See, all the forces are in the first quadrant, right? Fx and Fy are positive, right? From where the negative term come? There is no negative force. In all these problems that we have discussed, the inclined force in the first quadrant. So, we have gotten the Fx and Fy as positive, okay. Because if the force lies in the first quadrant, its components will be positive. Both the components will be positive, okay. Here, in this case, the force is lying in the second quadrant, as you can see, the second quadrant. So, if a force is in second quadrant, it will, and it is pull in nature, it's going away from the point, its component, this, okay, will also go away from the point and the other component Fy will also go away from the point. This much is clear? Fx will go away, Fy will go away. So Fx is going towards the left, Fy is going upward, right? Since Fx will be acting leftwards, I'll take it as negative, okay. We'll take it as, yes, right, very good. Yes, in this case, you have to take Fx as negative. Thank you, Preeti. Thank you. So, Fx is negative and you can take the magnitude of force as 10 cos 30. Now, you will not be having any problems in finding the magnitude of the force. As much as I have understood that you are not facing problems now to find the magnitude of the force, right? You are facing problems now to decide about the force, whether it's pull type or push type, or the components will be positive or negative, okay. Finding magnitude is clear to you. If theta is inclined with horizontal, take it as cos. If theta is inclined with vertical, then take the vertical as the cos, right? So here the difficulty is deciding whether it is negative or positive. We are taking the Fx as negative because the Fx is acting leftward. Leftward force will be taken as negative. So I am taking the component of F, which is 10 cos 30 as negative, and Fy would be 10 sin 30 and this will be positive. Got my point? Why positive? Because it is going upward. Clear? The force is pull type, so the components will also be pull type, and Fx is going leftwards, that's why it's negative. Fy is going upward, that's why it's positive. Clear? If so, Let's come here. See, the same force, but the sense is reversed. It is, the force is in second quadrant. Initially it was in second quadrant, but it was pull in nature. Now in this case, the force is in second quadrant, but it's reversed. Okay. Earlier the force was acting like that. Now the force is acting like this. Okay. So previously it was pull type. Now it has become push type, and everything else is same. Angle is 30. Magnitude of force is 10. Right? Like the previous. So in this case, how we can find its components? One thing, force is push type in nature, so components will be push type in nature. Okay. The force is coming towards the point, so the components will also be coming towards the point. Clear? Now see, when the forces are coming towards the point, where they are acting, the Fx is acting towards right, Fy is acting downwards. So towards right means positive, downward means negative. Towards left means negative, upward means positive. The reverse is happening. Rightwards positive, downwards negative. Okay. In first case, ma'am, in this case, negative sign use. Yeah, we'll use negative sign for Fy. Previously, we were using positive for Fy. Now, we will use negative for Fy. Clear? So, here Fx would be how much? 10 cos 30. Same. Previously, I had Fx as 10 cos 30. But it was negative. Now, it will be positive plus 10 30. Please make notes, because I am writing and this is becoming clumsy. So if you only rely upon this, you will be getting confused. So take notes. So previously the magnitude is same, but the direction is reverse. Previously the direction was in this way, now the direction is in this way. Since the direction of the inclined force is reversed, the component's direction will also be reverse. Okay. In previously Fx was going leftwards, that means in this case Fx will go rightwards. In this case, first case, Fy is going upwards, so Fy will go downwards in the second case. Why? Because in my first case, the force was pull type and I reversed it. I reversed the direction of the force, okay, and made it opposite. Since the inclined force is reverse, its components will be reversed, okay. So Fy here would be 10 sine 30 degree and it will be negative. Previously it was positive, now it's negative. I think it's clear. Clear? Am I wrong anywhere? Yes, sometimes I can be wrong. And you can correct me. That shows your understanding. Okay. Okay, let's move ahead to see two more cases. See, the same push type force, okay, a push type force here, the same 10 Newton force. The angle of inclination of the force with the horizontal is 30, but it is given indirectly in that way. So if this is 30, I can say that this is going to be 60, okay. In two ways you can go about this problem. If this is 30, you can take this angle as 30 and solve the problems, okay. This is Fx. I am leaving it on to you. Please do this and show it to me. This will be Fx, this will be Fy. You can find Fx by taking 30 as your angle of inclination, or this If this is 60, this alternate angle will also be 60, right? And in this case, same, the angles are reverse. This is 30, so this is going to be 30. If this is 60, this is going to be 60. And the forces will be directed like this. So I'm not going to completely do it for you. Please solve these two cases, find me the answer. Let's see how far you are right in understanding the resolution of force. Okay, so I think this has become too much for all of you, and I truly appreciate your patience in listening to me, okay, and taking part in the communication, right? Shall we end up the class? Let's wind up. Okay. I wish you good luck. Keep learning and be happy. Thank you. Let's meet in the next class. Bye.